class, go into the class in proper. As I still remain your host, your anchor, Mr. Simeon. We're going to be working on Python try except. And try except is trying to hold or undo errors for you. Like you're trying to write the program, and the program is giving you an error such as you dividing a first number by second number, and the person mistakenly entered a 0, 67 as the first number and 0. Then it flags an error called zero division error. I'm going to be writing a program that will undo this error before it turns to what crashes your program. That is everything about try except. So let's work on the try except program. I'm going to call it try.py. So let me increase this a little, the text font size a little. So we're going to be doing more in this, in letting you understand the concept of try except, and anywhere we can go today, that will be the end. So why do we use try except? Is to prevent the program from crashing due to unhandled errors. There are a lot of errors out there that you can catch with try except else, try except skip, all those kind of things. There's a lot of try except. So we have, it provides meaningful error message. Yes, the person would know that what is doing is not making sense. How can you say you want to divide 50 by 0? It does not make sense. You're not timesing it. You are dividing. How can you divide something by nothing? Then it's an error. So it helps in debugging and controlling what happens when an error occurs. So it even helps the program. So this is the syntax of try except. We have try, then we have your set of code. We call it risky codes. After try is risky codes. Risky code means this code might contain error. This code might contain error. So if it contains an error, mention the kind of error type it might contain and tell this code to handle that error. That is just the syntax. This is how it goes. You say try, you now put this, then you put your codes here. This is where it drops. There's an indent from here to here. There's an indent. Then you put your codes here. Your code goes here. Code goes here. So you write your code. You can write like your input, divide, anything. Then you press enter. Then you say except. That means in case of error, then you type your error type. What is the type of error? Is it semantic error? Is it a zero division error or something? You do your error type, then you have your handle error code here. That's all. This is everything about try except. You see how easy it is. So let's start with one very simple thing. Now, let's try writing the code. Okay, I think the next thing I'm going to be doing is to show you a basic example of the try except. So I'm going to be writing a try. We're going to ask it to enter a number, and it's going to be an integer number. If the person enters a correct integer number, it's going to say, oh, you are correct, you enter such a number. But if the person does not enter the right value, it's going to say value error, and it's going to say invalid input. Please enter a valid number. That means we can't enter an alphabet where we need to collect an integer. So let's do that. So we're going to say enter. Then we're going to say the number we want to test. Number to test. So number to test is an integer. Integer input. You know that is how we write an input. You are trying to collect an input from somebody, so you're going to do an int input function. So at this int input, you're going to ask it for a number and say enter a number. It is very clear and obvious that it is a number that we need. It is a number that we need. But somebody will still go ahead and write something that is not a number. So we are going to catch that. Sorry for where I kept this. It's supposed to be inside here, \n. So after the person writes it, I'm going to print. You can use to do a guessing game. You can use to get a guessing game. A formatted output, you can say correct. you you entered. Please hold on for me. My daddy is calling. Please. So we're going to say number to test is that we want to enter in a valid number. That means if this wasn't there, if this wasn't there, it would have been this. It would have been this. It would have been this. But there's nothing like this. It does not make any sense. There's nothing like this. It does not make any sense. There's nothing like this. It does not make any sense. There's nothing like this. At this stage, it does not make any sense. It does not make any sense. What we need is a number. So we're going to be asking somebody to enter a number, and we're going to print correct. You entered a number. But what about the person entered nonsense apart from a number? Instead of the system crashing, you're going to be having an except. And what kind of error is that? Is a value error. Value error. That is the error type. Sorry, value error. Now put a 10. So you're not going to put a print statement here. That is this print statement will handle the code. Sometimes some people can use a while here. You can use a while not number, not equals to number, not equals to a number, not equals to digits. Yes, then can you see that? That means as far as what the person is entering is not equals to a digit. Are you getting me? This still we keep asking. Enter a number. Enter a number. You just have to come here and copy this and put it here. Paste it here. It keeps asking, enter a number. So that means if the person here is messing up, is doing the wrong things, entering a number, this except to capture what the person is doing. Instead of your program to crash, what it will do is that it will keep asking the person to do what? Enter a number. So that is how we are going. I'm going into something very easy. So instead of doing that, I'll just say print. Please enter a valid number. Enter a valid number. This is what we are expecting to try. This is what is supposed to be the output after being tried. In case we tried and the person did not put the right thing, value error captures it and asks the person to enter a valid number. So let's do this. I'm going to clear the screen. And the name of my program is try. So I'm going to have it as Python space try.py. And we'll do this. It says enter a number. And I'm going to be putting a number such as 56. Was it correct? You entered, oh, sorry, we didn't complete it. Sorry, correct, you entered. Let's capture our value here, number to test. Number to test. So let's rerun. Let's rerun. Enter a number and we see 57. It's correct. You entered 57. Your program runs. What about the person does not run the program very well? The person made a mistake and say, Tiwa Savage. Tiwa Savage. Instead of your program to crash, it says, please enter a valid number. Did you get that? Please enter a valid number. So it simply means that this is not, for example, a lot of people used to make a mistake when they run a program, and instead of them to put letter 0, they put letter O or capital letter O. I've seen a lot of people done this before. So instead of putting 5 and 0, they put 5 and capital letter O. And this looks like, excuse me, please. This looks like 50. So when you press enter, it says, please enter the valid number. The person tries it again and puts 70 as 7 and capital letter O, 7O, and it keeps saying enter a valid number. And they will know that they are the one that are committing the error, and it is not your program that is crashing. So you have been able to capture the error as a value error, or you can even call it as a value error. You can come down and put it and say, if you are using this thing, if you are using a formatted output, you can say value error. please enter a valid number. So these are all the things that you can do. These are all the things you can do. So I'm not going to delete this. I'm going to keep this and comment it out. Possibly I might come back and need it again. I'll use it from here. So let's look at the model of what we gain from this. Now, what do we gain? Explanation. If the user enters something that cannot be converted into an integer, like I told you, the person enters a number and a letter, and it cannot be converted into an integer, the Python raises a value error. Initially, it's supposed to crash, but instead it raises a value error, and the except blocks catches this error and provide a friendly error message instead of letting the program crash. Hope you understand this now. Next, we move into handling multiple errors. Handling multiple errors. So you can handle, I purposely did this handout for you. So by the time I share it, you'll be able to watch the video and also read the handout yourself and do one or two things. Now, you can handle different types of error by using multiple except block. That means you can have this except block multiple times. Multiple times. So we're going to try to accept a number, accept another number, and divide that number by themselves and print out the result. Else the person enters a wrong number. We tell the person input invalid input, please enter numbers only. But what about the person even enter numbers and is trying to put the second one as 0? You can't and say error. You cannot divide by 0. So let's do that. We're going to be doing a try and multiple except. So we're going to do a try, and we're going to say we're going to pick a first number. I'm going to say the first number should be int input enter your first value. Pardon me, my typing sometimes, I'm used to big keyboard. So whenever I type on laptop, it jumps. So this is going to be the second number, which is going to be the second value. Now that's the second number, which is the second value. So the next thing we do is to come down and give it a particular operation, like as the risky codes. These are the codes that are risky. We call it the risky codes. So the risky code could be result. Result. We are going to be dividing. We're going to be dividing first number by second number. Yes, first number by second number. Then if it works out fine, then we ask it to print the result and say print formatted output. Then we're saying the results of let's do this, first number divided by second number is, they will not put the results. I know you guys understand this. You're a programmer. Now this is standard program. What about if the person tries nonsense and enter 5 and capital letter 0? So that's going to be a value error. That's going to be a value error. They're going to say then, if it's a value error, print invalid input. You are handling a value error at that particular place, so you're going to be putting invalid input. You're going to say, you want to say, please enter valid numbers only. Please enter numbers only. Thank you. But what about if the person enters number and both of them are actually numbers, but it's actually dividing a value by 0? We're going to accept that again. We're going to say 0 division error, just like what you saw inside the error log at the other time when I started. 0 division error. It's an error called 0 division error. And you're going to be printing, you'll be like an Hausa man, you're going to be like, Kai, please try. Don't ever, you can say error, don't ever use a 0 to divide an integer. Error, you cannot divide a number with 0. So this is it. This is a multiple else, except statement. Multiple except statement. We have a value error that we undo, an error of entry of numbers, entry of letters, and we also have a zero division error that we undo, error of 0 divided by an integer. So let's give this a try and let's see if this works. Let's see if this works. So I'm going to be running my try program. As I enter the first number, I'm going to be having 50, second number 78. And it's telling me first slash num. So it's supposed to be first number, not first. That's the variable here. So let's do that again. Control backtick. Can you see this error? See the way it spoiled my program. That's what you are trying to undo. This one is actually in program writing, not complete program writing. So this one is completed now. Let's check 69. Then, okay, the class running off. So from here, I'm going to be stopping this class. After running this program, that we are creating another link I will be sending to the group. Then you join on from there. You have 79. I press enter and say the result of 69 divided by 79 is this. So that is the end of the first part. Please join me on WhatsApp and get the second class link. Thank you. So this is what we have at the running of the first risky code, and the person obliged by entering what he or she is supposed to enter, and the program ran correctly. No hanging, no error, nothing. But what about if the person ran into the first type of error using an alphabet instead of an integer? Then it goes like this. He cleared the screen and the guy runs the program, like he clicks the icon of your software and it says enter your first value, and he enters 50, and he enters second value, he enters 20 as 2 and capital 0, and he press enter. Then it says invalid input, please enter numbers only. The person would have to go and look and say, the 0 here is actually a letter O with a slash, and let's make it look like a theta. And this second one, it looks like letter 0 without a slash. So in one way or the other, definitely this is a wrong. So something captured that. Something captured that. That is a value error. That is a value error. Invalid input, please enter numbers only. You cannot divide 50. You cannot divide 50 with, let me see, I'm to bring it up back. You cannot divide 50 with 2 and capital letter O. The third one is a zero division error. Let's try to run the program. These are the second except. Let's try to run the program and enter 60 divided by 0. Let's see what will happen. Then you have error. You cannot divide a number with 0. So what are we saying? That means you capture two errors. Capture two errors inside. And you can also do something. You can also do something by saying name and collect the person's name by saying input and collect the person's name. Then if the person did not write his name, you can come back in your software down here and pick empty value error, except empty value except, and say print you did not enter or fill your name. Do you understand how we can add except to your code? So I want you to check out how many types of errors do we have and how many you can add to your code. I was able to do 2 for you, and see how long you can make your code to be. Now, what is the implication of what you just did? The explanation says value error is handled if the user enters a non-numeric data, such as the way I entered a O instead of 0. And zero division error is handled when the user tries to divide by 0. So there's something called using else with try except. So we have try except else. We have try except final. You see final. We have try except finally. We have try except else. Why do we use else? It says you can also use an else block to define code that should run if no exceptions occur. That means you should try if the number equals to a number and there's no value error, there's no zero division error, then it should come to else and run you entered the number. So what are we saying? Skip everything and try and get number. Try and run the code. So this is how that one goes. It goes by saying try. You can decide to say try first number, try second number, and do something. But since you're working on else, I can decide to call it first value. First value. Now, it say enter your first value. So you can say, you can decide to throw an error immediately here. So you are trying to come to else, don't forget. You are trying to come to else block. This is where we are coming. Okay? But while we are here, we are still trying to get if the person entered a wrong value. So we say invalid input, please enter numbers only. But when the person enters a real and a correct value, else do not have a error name at their front like the way except as. So if there is a else, the next thing you do is to capture what the person does, such as you entered first value as your value. So if you run this, let me explain this what it means. We actually wrote a risky code here. Then we now say if the person enters a right choice, then he goes and executes the code, which is else. But if the person writes a wrong choice, value error captures whatever the person writes and brings this for the person while the software is still running, while the software is still working. So it goes, it picks it and it stops here. It does not crash your system, it does not crash your software. But if it's a right thing, it can't say and print this out. What's the first value? 50. Then it says you enter 50 as your value. What about if I run it again and I entered 5 and 0? What will it do? To tell me that I didn't enter a valid number. So I can say 5 and capital letter, yes, 501. But I actually typed 50I. 50I, O and I. It's an invalid input. Please enter numbers again. So how did it run? I said earlier, like I've been talking here, that when you do a try, then the code will run. But so it's a different case. Why do they try? Is keep a code and come to the original code. That is what try except else does. So let's get an in-depth explanation of what try else does. Try except else does. It says if there is no error, the code in the else block runs. This makes the code more organized. So you can trap code errors at the beginning of your program. By the end of everything, you put a else there just to say, okay, what about if all these codes are being jumped over? Let me pick up on the right one. So that's it. So I'm going to be talking about the using the finally block. How does using the finally block works? I said the using the finally block runs no matter what. Whether an error occurs or not, It's often used for cleaning up of actions, like closing of files in a database connection. Now, this one will make me quickly jump into a concept I have not taught you before. How to use Python to read a particular file. How to use Python to read a particular file. Then I'll now continue from there and teach you try except in trying to read a file. So let's write a small program for using a Python to read a file. So everybody notice that I have my Python opened here. My Python is opened here and I have all my work here. There's a file here called data. It says Python programming class. Let's add more. What else can we add more? We can say I am enjoying Mr. Simeon's class a lot. A lot. I'm enjoying it a lot. So what we're going to do is that we're going to come to our code. It's in the same folder. It's in the same folder, data.txt. See, try data.txt is in the same folder such as my programs. So my program will definitely see it by default. So let's write a program to open what we call it open a file. You can open a PDF, you can open a Word document and use Python to read it. That's why Python can be used for cybersecurity such as hacking. So let's do how can I write a Python program to open a text? So what we do is that you write file equals to open. What are you trying to open? You are trying to open the name of your file known as data.txt. That is it here. Yeah, this is data.txt. So what you do is you come back here and say file open data.txt. Then we have different kind of ways after a comma. We have different kind of ways you can open that file. We have the read mode, we have the view mode, and we have the write mode. Do you want all the three privileges? Possibly yes, possibly no. But for now, we just want to read. So like I told you, read is what? R. Read is what? R. File equals to open this file on the read-only mode. That is what it means. So you're going to come here and assign a value here. This is what we'll be joking with throughout your file. The file name is now called data in our company. So it's called data equals to, we're going to do something to read. We're going to tell Python, go and read this file. Python, we have said you open this file using the read privilege. Python, you must read this file and tell us what you have inside of it. So it's telling us that Python, read this file. How do we do? We use the read function. This is how you write it. You read the read function. So you have to say file dot read. Everybody study this. You're going to be using it for machine learning, please. You're going to be using this code for machine learning. Data equals to file dot read. Then you're going to be putting this inside. Then Python has read it. Python has read the file and it's asking, what should I do? We're going to tell it to print what? Print what? This. I told you, print what's on the left. Don't print what is on the right. Print what's on the left. You're going to print data. That's what you're going to print, data, because data is what you have on the left and comes down on the right. So we're going to clear this and we're going to have this. Now everybody look, I never look at my code. Look at my code. This is try except. This is try and except else. I never wrote Python programming class. I am enjoying Mr. Simeon class a lot. I never wrote it anywhere here, but because it's inside the data.txt, it reads it. So if it's a PDF, what would you do? You come here and add PDF. If it's a Word document, you come here and add doc or docs like this. If it's an Excel file, that's XLSX, depending on what, or XLS. If it's a PowerPoint, it has PPT. So you have to know the extension PPT, and we have PPTX. So you need to know the extension of your file. My own is txt. So let's write a Python try except that will do what? That will write a finally block that will still run the code despite, let me show you, despite it's often used for cleanup action like closing of files and database connection. Now you are not learning utility codes in software development. So if the finally block runs no matter what, whether an error occurs or it does not occur, it does not concern him. So it is often used for cleanup actions like choosing files or database connections. So let's do reading of the file from here using a try, which is very, 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 very accurate in our program. So you can read the program. I will not do file not found. I know many people have seen this error before. File not found. File not found. So if the file is not found, you should print file not found. But finally, if the file was actually found, it should bring it out and print file close, and it should call out the file. Now it's going to call out the file, but it's not going to print the content because um, pulling out something and printing the content is different from pulling out something and just trying to view it. So let's work on this. Let's work on this and say try. Don't forget try except start with try. We're going to say data, just like we did folder. So we're going to do data into open bracket. Then we're going to be having the name of the file in a quotation mark data.txt. And how do I want to view it? It's in a readable format. Control R in a readable format. Now, what are we going to do next? We are going to read that file, just like we said, data equals to, oh, sorry, everybody. This is supposed to be, I just see this now. File. File is the first thing you write. File equals to open. Second one is data. It's because I wrote this data now, I saw that it was two data and it's not supposed to be two data up there. So we are not going to be having file dot read. You are going to be having file dot read. They are going to ask you to print the content of the file by saying print data. We are done with try. But let's try an except of file not found. Let's do an except. Except the file not found is an error. Except the file, you see that it turned green, which means Python understand file not found error. That is what means Python understand file not found error. It has a meaning to Python. So you can print that your file wasn't found. Okay, so when we have done a try, except, now we're going to end it with a finally block. We're going to say finally, what should happen? It should close the file it read. It should close the file it read using the close function and print out file dot close. This is what's going to happen to the screen. Going to display to the screen file close. That's all. That is all. If you look at what we have here, that's all we have regarding the finally block. So we're able to open our file here. File open, file data.read, then print is delay. Then if the file name was not found, then we could say finally do this, do that, do that. Then this is a file close statement because this is a close function and this is a open function, which is read, and this is close. So we're going to run this and see if it will run. Okay, that's control backtick. So I'm going to run this program again and see what we are saying. So it came out after reading it and it stopped it and it says file close. It says file close. So please, this is not cramming. I didn't cram it, it's just step by step. You need to understand it. If you practice, you will understand it. So what I just did here is to use a Python file opening statement and come here and use this one single line. It's just like sometimes some people write a program and say self.destroy. When you do self-destroy function, this comes from Python itself. That whenever they click that button or they click anything regarding that interface, it breaks the interface, it crashes the interface, it closes the interface. That's what we mean by that. But file.close only closes the file for the temporary time and opens it again in its due time. And this is file close will be under it as the company's decision. Do you have any question or I should continue? So that is that about that. I'm happy you understand it now. Let's check the explanation to what you just did. It says the finally block ensures that the file is closed. See, finally says the file should close and it prints that the file is closed. So despite the program, whatever runs or whatever does not run, the finally block ensures that it closes the file, and even if the file not found error is raised, it will still close the file. That is one good thing about it, that no matter what happened, either error or without error, make sure that that file is closed. So you can catch all exceptions. You can catch any exceptions using a general except statement without specifying an error type. However, this should be used carefully to avoid hiding unexpected error. So don't say because you want to write a program for somebody and deliver it, you are trying to use try except without giving an exceptional error name, without supplying an error name. It will run though, but all the people you wrote your program for, they will complain because the output will not be correct and it will not be right. So let's try this and let's be the last topic we discussed in this class for today's class. Then we'll continue tomorrow. There's going to be class tomorrow. So we're going to do try, enter. I'm going to do some codes such as x equals to 5 divisible by 0. So you can come back and say except, then you can go back and say print x, print x, or if you print x, an error will occur because it will flag a problem. But we don't want the error to occur. So I'm going to say an error occurred. That's it. An error occurred. Because even you yourself know that the code you wrote is wrong. So if I even say first value equals to enter what it is, second enter what it is, and it comes to x and divide by 0, there will still be a lot of problem. So let's run this one. As it will be the last one for the class. It's an error occurred. That is an error in the program. So you can decide to elongate it more by saying x equals to, just want to add it to a variable. Let people guess what they want themselves instead of using 5 and x. So let's say int input, what is your number? What is the number? Then it comes in by saying y equals to, we've already collected x, then x comes here, divided by 0, divided by 0. So we're going to be printing an error code. It's not printed the result here, it didn't print 1, but we printed an error or code. So let's run that. And you'll be having what is your number. invalid syntax. See, this is another syntax error. This is another syntax error that you can pick. You can pick another error called syntax error. So we say, what is your name? It's not recognized. So how do we properly write what is your name? Okay, we didn't put this and we don't put this. Yeah, then it will run now. What is your numbers? What is the number? I can say 78. And I say an error occurred. Said an error occurred. So it will run basically. No matter what you say you should do, it will run. So what is the expectation, or what is the explanation in this code? The explanation is that this will catch any exception, including ones you might not have anticipated. This code will catch anything. It is good for catching unexpected errors, but to be used cautiously in software development and also machine learning and AI. Thank you so much for the class. Really appreciate you. Next class, we'll be doing raising an exception, nested try accepted, nested try except block, and file handling with try except, and summary of try except, and what next? What next? So that is all about today's class. I'm happy to be your anchor. Thank you so much, and God bless you.